maybe we'd be able to take people who are dying and then at some future time point, pull them out and then they can continue living. What's irreversible at some time point might not stay irreversible. People should be able to, if they want to, end their lives at the point where they're suffering. But on the other hand, if we have people who are terminally ill, but who think that this might give them some chance at more time, it's absolutely something they should have access to as well. I actually think we already have the technology available today in order to preserve people in high quality. Prior to the late 19th century, 1 in 2 children died before they reached the age of 15.
Don't Be Caught Dead, the show bringing stories of death back to life. Here's your host, Catherine Ashton.
Today we're speaking with Ariel Zeleznikow-Johnston, a neuroscientist based in Melbourne, and the author of The Future Loves You: How and Why We Should Abolish Death. He is currently a research fellow at Monash University, working within the Monash Neuroscience Consciousness Laboratory. His research focuses on developing novel methods to characterize conscious experiences, contributing to the broader effort and to understand the neural basis of consciousness. Ariel completed his PhD at the University of Melbourne in 2019, where he investigated how genetic and environmental factors influence cognition in both healthy and diseased brains. He has published extensively across the field of cognitive neuroscience, with work spanning the decline, preservation, and restoration of cognitive function across the lifespan, as well as investigations into how people consciously experience colour. As an author, Ariel explores how cutting-edge neuroscientific developments may one day make it possible to suspend death through brain preservation, potentially offering individuals a chance of future revival. His work examines the scientific, medical, and philosophical foundations underlying this radical proposition. Thank you so much for being with us today, Ariel.
Thanks for having me on the show.
I have to say, I can't remember how I came across your book. It might have been an interview that you did on ABC radio. And I went, oh my goodness, who is promising a future without death? Is this possible? And so, needless to say, I went and purchased the book and have been taken on a fascinating journey for the last month of reading it. So tell me, what drew you to this particular avenue of neuroscience and more specifically, when we die and what happens?
Yeah, so my background is as a neuroscientist, and I've always found neuroscience in general to be fascinating because it's the combination of big philosophical questions of who we are and what it is to be conscious, what it is to be a person, combined with the fun sort of nitty-gritty of like, how does biology make us who we are? How do our brains actually function? What are all these like squishy cell things doing? And like, that's what I've been working in for the past, I guess, over 15 years now or so. But at the same time, as working as an actual scientist, I've always been really interested in both the past and future of scientific and medical developments. So things like looking back to how we got to the world we have today, where we have, antibiotics, surgery, anesthesia, compared to the primitive state of the world a few hundred years ago. And also looking forwards to, well, what sort of things do we expect to come about in the decades and centuries to come? And as part of that, I enjoy reading sci-fi and watching sci-fi. And in particular, there's one sort of technology that's often explored in science fiction that is quite relevant to, discussions of death and future medicine, which is this idea that like maybe we'd be able to take people who are dying, somehow put them in stasis where they're unchanging, unaging, sort of inert, and then at some future time point, pull them out and restore them to health, cure their cancer or injury or whatever was harming them, and then they can continue living. And when I came across this, like in Futurama, for one example, or in the movie Interstellar, these sorts of depictions, I used to wonder, like, is this really real? Could it be real? Is it just a plot device that's used in stories, or is there something to this? And like, I guess I'd always speculated on that in the back of my mind. But in the past decade or so, I kept coming across, I guess, new developments that made me think maybe there is something to this sort of idea of being able to make it work. The two big things being we've developed a much better understanding of how memories are actually stored in the brain. So, like the structures that underlie sort of the continuation of our psychology over time. And also, some of the technologies to preserve brains and preserve bodies has gotten a lot better in the recent past as well. So being aware of those, I was like, well, maybe it would be good to actually dive in and see if anyone has written like a proper write-up of like, this is why maybe it could work, or actually here are all the technical reasons why it's forever impossible. And when I went looking for that, I realized firstly that there was no long-form analysis of that. And secondly, that like perhaps I was in a particularly good place to do the assessment. And so that's how I ended up doing the work and writing up the book.
And I think that was interesting, the fact that when you were looking back, it made me really realize how far we have come in such a short period of time in relation to, a condition such as diabetes. You may have, died of that many years ago, but now it's something that's just, you can just take a tablet and you can manage it, or you have insulin, and there was many case studies that you use throughout the book that clearly, give an example of just how far we have come. So it made me start thinking, well, I do wonder what we're going to develop in the next 100 years and what that's going to look like.
Yeah, it's very easy to take for granted the medical technology we have today as basically always having been there, or as like the absolute bare minimum standards of what we expect people to have. So whether it's things like insulin for diabetes, whether it's dialysis for people with kidney failure, whether it's statins for people with heart disease, these are all like very common and ubiquitous today. But most of these things were only developed since the last 19th century or so. And there's a lot of people alive today with chronic health conditions who just would have died in earlier times. In the most dramatic sense, it's the case that prior to the late 19th century, 1 in 2 children died before they reached the age of 15. So we really shouldn't take what we have today for granted. It's miraculous what we can do. And hopefully people in the future will look back on technology we have today as equivalently primitive. At least that's what I think is worth exploring and taking seriously.
And let's talk about how you discuss that within the book. So I found it really interesting that the medical term of when you're actually the definition of death, I found that fascinating. Could you maybe talk through that, like how that is?
Yeah, I think it's useful probably thinking through it with a bit of historical context of how the definition of death has changed over time. So prior to the middle of the 20th century or so, people were defined as dead just based on, they stopped breathing or their heart stopped. And that was a perfectly functional definition because at that time point, there wasn't anything we could do for people who'd stop breathing or stop having blood flow. But with the invention of things like ventilators to help people breathe even when their lungs had failed, and then subsequently things like cardiopulmonary bypass machines, so devices that could keep people's blood flowing even when their heart had stopped, it became apparent that, there were circumstances where it seemed like people were still alive despite heart and lung function having at least temporarily ceased. So in the 1950s and 60s and onwards, people realized that we needed a more sophisticated definition of death. And in particular, in the US, there was an effort by legislators and ethicists and doctors to come up with something which ended up being called the Uniform Determination of Death Act, which involved defining someone as dead based on one of two possible definitions. The first was that they'd suffered irreversible cessation of heart and lung functions, so essentially the old definition. But the newer definition that they also used was defining someone as dead based on irreversible cessation of all functions of the brain, which is what we commonly think of these days as brain death. So what that definition acknowledged was that there are circumstances where, sometimes people's hearts and lungs have stopped for a while, but they can be brought back, and so they're still alive in that sense. Or there might be circumstances where people's hearts and lungs are still functioning, either intact or with support from medical machines, but the person's brain has essentially been destroyed and they'll never be conscious again. Their memories are gone, their personality's gone. And maybe in that circumstance, it feels like the person has been lost and should be defined as dead. I think that was passed in the 1980s in the US, and it then became used generally worldwide, including in Australia. But even at the time, people noted that there were still problems with this updated definition of death for two reasons. The first was it defined people as dead only if they've suffered cessation of all functions of the brain. But if you actually go and you look in the brains of people who've been declared brain dead while still being kept on some life support, so heart and lung function, you can often find little bits of brain activity that are still going. So, for example, their hypothalamus, a small brain region controlling like body temperature and some instincts, is often still functional in these patients. Doctors are just like, well, like that doesn't really matter. It doesn't count. Like the memories aren't there. The consciousness isn't there. It doesn't matter if their body temperature is still going, which I think is fair, but it does suggest that there's something wrong with the definition. The other part that's also problematic is this irreversible cessation of all brain functions being part of the definition, because what's irreversible at some time point might not stay irreversible. So in the same sense that, once upon a time, if your heart and lung stopped, you had irreversible cessation of heart and lung function. Nowadays, we have machines to replace those. In the same way, we're increasingly developing better and better sort of brain implants, neural prostheses, which can replace lost brain functions. And there's a question of, as that continues to get better and better and better, how are we going to define irreversible cessation of all brain functions as part of a definition of death? And so, given all that background, that's why I and some other philosophers have a slightly different and I think better definition of how we should be defining people as dead.
Well, I just have to ask, Ariel, what is that definition that you're proposing?
Yeah. So a definition that was first proposed again in the 1980s by, on the one hand, some bioethicists at Harvard, and also almost simultaneously by a computer scientist, was this idea that instead of defining someone as dead based on loss of heart functions or breathing or irreversible loss of all brain functions, including things like controlling your body posture or controlling your breathing rates, what really matters is, for someone's survival, is that their consciousness still exists, that their memories are still there, that their personality is still there, that the things that make them them in a psychological sense are still continuing. And what they proposed is that, well, if those are the things that matter for survival, then the definition of death we should be using for when a person stops is when those things are lost. So basically defining death as the irreversible loss of personal identity. And what that implies is both that there might be circumstances where, someone's brain activity has stopped for a while, either under anesthesia or in a case like induced hypothermia, or even in the weird preservation cases that I speculate on, where as long as there's some chance someone could be brought back in the future, that they may actually still be alive. They're just, not currently conscious. And that there might be other circumstances where, someone may have suffered extremely severe brain damage to the point where they've had massive personality change or where they'll never be conscious again, where it's arguably questionable that the person is still there, even if there's some very primitive functions remaining, like being able to drive breathing or maintain body temperature or those sorts of things.
Yeah, it's interesting. I think that what really, in the examples that you use, were people who have had acquired brain injuries, how that has impacted on their personality and who they are as a person, both before the injury and then after the injury, and then also both from their reflections, but also those perceptions of those around them, I thought was really interesting. And also the fact that, the ability to make memories from there on in, like if you have had some damage sustained, how much does that actually create who we are as a person? So I find your whole discussion around this topic really fascinating. And perhaps if you could explain the term connectome, because I know that you speak a lot about levels of consciousness and what consciousness means, where memories are stored in the brain, where we think they are, where we there's still so much to learn. But something that I did take out of your book was that term connectome. And I'd love if you could explain that to us.
Yeah. Okay. So I think one thing I should just be very clear about before I get into this is just, I want to make clear that I don't think any amount of brain damage or trauma is sufficient to, stop a person from existing or turn them into a different person. There's all sorts of circumstances where people have mild brain injuries or concussions or things where, there's definitely a loss of neurons and some damage, but we continue to think that someone is still the same person. Kind of what I get into in the book, though, is we can see these circumstances where there's increasing levels of change or increasing levels of damage up to the point where there's complete brain damage and complete loss of consciousness. And the question does arise as to what level of damage or what level of integrity is required for a person to continue to exist and continue to survive. Now, as part of trying to really give a technical answer to that sort of question, you've got to ask, well, what is a person? What is their brain? How does the structure of someone's brain contain and give rise to their psychological properties? And as part of that, to finally get to your question about what the connectome is, that's the term that neuroscientists use for the complete set of connections between brain cells in a person or an animal's brain that store all of the neural information that makes them who they are. So their memories, their personality, all the things they've learned, or all the things that shape their behavior, that gets referred to as their connectome. And to be really specific, for a human, that's all 86 billion or so neurons in your head, plus the roughly quadrillion connections between those neurons. And for different animals, it'll be different numbers. It's a homage to the term genome, where genome refers to the full 20,000 genes or so that make up each individual. Your connectome is the full set of neural connections that give rise to your psychology.
And I think when you stipulated those numbers in the book, I'm like, wow. And I think the comparison that you drew to current computers and what their computing capabilities are, and then when you compare it to the current brain, our brains are really working hard by comparison.
Yeah.
And the figures really blew my mind when you actually think that, this is all something that happens naturally.
Yeah, one thing that's incredible is today's most advanced supercomputers have computing power that is probably roughly equivalent to a human brain, except a human brain can run on a sandwich, and these computing clusters take essentially small power plants worth of energy to run. So we are much more energy efficient than these things. We're a bit slower. They work on faster time speeds due to the electronic components, whereas human brains work on, tens of milliseconds, hundreds of milliseconds, so eons compared to them. But in terms of energy efficiency, they've got nothing on us yet.
I like that. It makes us feel that we're not redundant,
Not for a few years, at least.
Yeah, that's great. But it does really make me think just how difficult it must be to try and work out what functionality is associated with what parts of the brain when you see that there's that many different, electrical components as part of that you speak about. It is phenomenal.
Yeah, I mean, so on the one hand, neuroscience is still a very long way from being able to give a full description of how the brain works. In particular, we're stuck on questions of how exactly is it that the brain gives rise to consciousness? That's still a long way from now. On the other hand, we have made a lot of progress over the last century or so in understanding some of the basic elements and even some of the more complicated ones. So in the book, for example, I outline with human studies, you can learn quite a lot from looking at cases where people have had particular kinds of brain injuries, or they've taken particular kinds of drugs, or they have particular kinds of developmental variants, and seeing how individuals in those circumstances differ in their behavior from those with, more typical brain structures. So to give some examples, we know that memory depends on the hippocampus to a large degree, because there are cases where people have had damage to the hippocampus and they've been unable to form long-term memories going forwards. Or we know that there's other circumstances where, for example, there's these pair of twins in Canada that are conjoined at the brain. So essentially they have what would look normally like two brains that have been joined together into one brain, I guess. And they report in some ways having slightly different experiences and still being separated, but on the other hand, being able to share a large degree of neural information. and like being able to see out of each other's eyes, for example. And that also gives us a bit of a sense of, what functions are localized to which bits of the brain and what gets shared and what doesn't. So that's from a human perspective. Simultaneously, we're getting better and better and better at being able to manipulate the brains of animals that we can use to learn more about, neuroscience generally. To the point where these days, there are techniques that can be used to like label the specific neural circuits involved in the formation of a particular memory and even erase particular memories. Like there's some great studies that have recently come out where they train these mice to do two different motor tasks. One was like balancing on a high beam, and one was sort of like balancing on a rotating rod. And then they showed that they could map like which circuits were involved in each of the tasks, and they could selectively erase only one of the two while leaving the other one intact. And from doing these sorts of experiments, we learn, that memories do depend on specific sets of connections between specific populations of neurons in a way that we can then generalize to how it is that human brains function as well. So there is quite a lot of progress being made in this area.
Yeah, I found that the evidence and the research that you refer to all the way through is very compelling because it does support just how far we have come over the last 100 years in understanding the functionality of the brain, but also answering a lot of those like big philosophical questions, that you do tackle. And there is so many different philosophies that you refer to in there that were fascinating just in relation to how our brain functions, how we function, memory. It was really quite amazing. When you're thinking about consciousness and referring to the connectome, what is it that's so important about understanding that when we're talking about death and the possibility of cheating death in the future?
Yeah. So in an ideal circumstance, we would be able to give to people who were dying some sort of pill or drug or standard treatment that would just cure their cancer, cure their heart disease, just give them continuous years of healthy living without any sort of complications about weird neuroscience, philosophy problems, any of those sorts of things. It would just be a simple standard treatment available to people. Unfortunately, I don't think that's going to become available anytime soon. And the only prospect I see as being able to help those who are dying but wish that they could have more time is the possibility that maybe we could take them and preserve them in some sort of unconscious, inert state for a period of time. But if that's what one is proposing, you've got to make claims about like why you think that person isn't necessarily dead, or why you think you might be able to revive them at some point in the future, and how it is exactly that you would be able to revive a preserved body in some way. And getting into those questions involves really getting to grips with like, well, what exactly is a person? What does it mean for a person to be alive? What does it mean for a person to die? What sort of changes can happen to a person and still have them be the same person? All those sorts of things. And that's why I had to get into the neuroscience and philosophy of really drilling into these topics, because I'm kind of speculating on the development of technology that I think will maybe one day exist, but I'm making the case for it, but it doesn't yet exist. And so one has to understand the possibilities.
We've been fortunate enough to speak with the founder of Southern Cryonics last year on the podcast, and they successfully have cryopreserved the first person in the Southern Hemisphere last year. What is like cryopreservation? How does it differ from what you refer to in the book, which is a different process, which is vitrifixation?
So the general philosophy is the same in both circumstances, where it's this idea that maybe you can take an animal, a human, a patient, preserve them for a while, and then restore them back to biological activity and consciousness. And it has precedent in the natural world and the scientific world for things that are already, actively working and ongoing. So some examples are, there's these things like the Arctic wood frogs, these frogs that, they freeze every winter, and then they thaw out come spring and they go back to hopping around.
Yeah, that's bizarre.
Yeah, it is bizarre, but it's also something we can do with humans, at least with small bits of biology. So, it used to be sci-fi in the 70s and the 80s, but today there's a lot of people who have already been, frozen for part of their life in that we routinely cryopreserve sperm and eggs and embryos in IVF and assisted reproduction therapies. And what happens in those circumstances is you'll take an embryo, you'll lower it to very cold temperatures, and you'll also add in some antifreeze chemicals, which will prevent ice formation and ensure that when the embryo is preserved, it's preserved in more of sort of a glass state at cold temperatures, rather than in a crystalline sort of ice state. That's what's used routinely today. The issue, though, with trying to scale that up from embryo sized to organ sized or whole human sized, is that the chemicals required to prevent ice crystal formation, these antifreeze chemicals, they can cause some degree of dehydration of the tissues that you're trying to preserve. And indeed, if you try and do cryopreservation of a whole human using just these antifreeze chemicals, as per the Southern Cryonics case that you mentioned, what we typically see in that circumstance is that there's a lot of shrinkage of organs, and particularly of the brain. So if you look at the brains of patients preserved this way, you'll see something like a 50% reduction in the size. So the brain's kind of shriveled by about half, 30% to half in these circumstances. And that's not super encouraging for thinking that the brain is still intact and all the connections between the neurons in those brains that store someone's memory and personality and everything is still in there in an intact way. It might be the case that there would be ways to reverse that and, expand it again, and maybe the connections don't break when they're dehydrated, but no one has shown that in a sort of definitive way as of yet. So it's a concern that I have. Instead, though, there are other ways of doing preservation that don't induce this sort of like shrinking related damage, which have better evidence behind them as keeping someone's connectome, keeping someone's brain intact. In particular, there's a method that involves what's called fixation. You take an animal or a human and you introduce preservative chemicals, formaldehyde, glutaraldehyde, into their sort of circulatory system. And what those do is they permeate everywhere. They get inside all cells, they get inside all the small organelles within cells, and they fix them in place. So they stop them from moving, they stop any sort of further decay processes. And in doing so, they can give you very high quality preservation. So you can then look at the brains after this preservation procedure and see that the connectome is still intact, the neural connections are still intact. That's the main advantage of it. The disadvantage is that you could not, in principle, just take this and, warm the body back up again, and it just goes straight back to operating as it did previously. That's what we can do, for example, with, cryopreserved embryos. And that's what the people who hope to cryopreserve whole human bodies wish could happen. Maybe they'll develop a protocol for that one day. But with the fixation preservation, you need some more advanced revival technique to be able to restore the person to consciousness. Now, I think that's very plausible that we will have that one day, but that's the trade-off between the two different ideas.
And Ariel, I was just wondering, there is currently in the Western Australian Gallery an exhibition which is saying that it has, I'm bringing it up so we can have a look at it together. Have you seen this yet?
I'm not sure exactly what you're referring to.
Okay, so what it is I only found out about this on Sunday. I think it's vivification.
I can guess while you're looking. Is it one of those exhibitions where they have the preserved human bodies either plastinated on display?
No, it's not a Bodyworks kind of. Yeah. I know where you're going with that one, but no, this one, I'll read this to you and see whether you can help me with this one. So it's currently on at the Art Gallery of Western Australia. It's entitled Vivification. Vivification is an extraordinary immersive exhibition combining sound and cutting-edge biological innovation to bring to life the musical genius of a deceased composer. 4 years in the making, Vivification delivers a historic first, the in vitro, external they say, brain of the late composer Elvin Lucier, I don't know whether I'm pronouncing that correctly, from 1931 to 2021, they were alive, creating a new work in real time as a live performance over the duration of the exhibition. So it's actually been developed with an artist by the name of Guy Ben Ari, Nathan Thompson and Matthew Gringold, with a neuroscientist, Stuart Hodgetts, based in the University of Western Australia, who individually spent 25 years pushing the boundaries in biological arts.
I am not
Wow.
sure exactly what they have done, but it does remind me of something I explore in the book, which is this question of like, could you take brains and recreate them in some sort of digital format in a way that captures the function, behavior, memories, everything that was in the original biological brain? As an example of the sort of current cutting edge progress that's been made in that, late last year was the first publication of the like full mapping of a fly's connectome, a fruit fly's connectome. So it's 160,000 neurons and billions of connections between those neurons were fully mapped out. And from that mapping, the neuroscientists made a sort of like digital recreation of that fly brain. Now, they didn't make it in perfect quality, as they themselves acknowledge, but even their sort of digital version of this fly brain was able to show some of the behaviors of the original fly. So, for
Wow.
example, they stimulated some of its neurons that correspond to tasting sugar, and they saw outputs from the motor neurons that corresponded to it trying to extend its proboscis, or essentially like stick out its tongue. Now, I
Wow.
use this example both as one to demonstrate this is like cool, and these are the steps that are made on the way to maybe being able to show one way of reviving preserved humans in the future, but also to make very clear that we're not up to humans just yet. We're just trying to
Yeah.
get things like flies and aspirationally mice in the next few years to work. So this example in Western Australia, I'm not exactly sure what they're doing, but it's definitely not the case that they've managed to upload this composer as of yet.
Yeah, yeah. I think they may have taken a bit of poetic license with the exhibition description. But it's fascinating to know that that's where we're currently at this point in time. So I'd like to talk about the future and the process that you sort of outline using what we see and the example you've just given us then with the fly. What do you see developing over the next, 100 years, 200 years, and what does that look like for us?
Yeah. So, in advocating for preservation as a means of providing those who are dying but who would like to have more time a potentially viable method for doing so, it's sort of a two-part technology. There's the initial preservation and storage side, and there's the eventual revival side. And we can examine each part individually. So I actually think we already have the technology available today in order to preserve people in high quality. And the issue is mostly around public knowledge that it exists, public acceptance, the rollout and integration of it as part of routine medical technology. It's of no use to anyone if, there's no provider that's available to integrate it into hospices or hospitals or a place where terminally ill patients might be able to access it. And even if it was there, if nobody is aware of it or wants to make use of it, then there's no point. But I do think that the technology to preserve people well today does already exist. And there's a couple of groups on the west coast of the US that are trying to provide it commercially at the moment. But that's only the preservation side, and then keeping people in storage. The question is, like, at what point would you maybe be able to restore those individuals back to consciousness? And there's sort of two ways people imagine maybe being able to do so. One is through sort of directly reversing the preservation procedure itself. So undoing the fixation that happened with those preservative chemicals and then, I guess, warming the person back up again. That would require sort of very advanced nanomedicine, far beyond what we currently have, and sort of more in the scope of what it is that, biology can do, like the machinery within our cells, the machinery of other life forms that's currently still far beyond human medical capabilities. So that's one side. The other possibility is more similar to what I was mentioning with creating digital brains or uploads just then. And actually, the avenue that I think is likely to arrive sooner, which is the idea that it might be possible to take a preserved individual's brain and body, to scan it at very, very high resolution, and then to create them a new sort of artificial, electronic, digital brain and possibly body to go along with that. So looking at what's been happening, for example, in the fly example I mentioned, and sort of making that better, making that work at scale, increasing the computing power and the knowledge of neuroscience to the point where we can do that to a human. with estimates of that being possible, I don't know, sometime between the 2060s or early 2100s, depending on how optimistic the neuroscientist in question you ask is.
Because I suppose when the reference that you made previously about the genome, when you think how far we've come in just the fact that everyday knowledge now, we know that genome and DNA, we can do DNA testing ourselves in our home kit, so it's come a long, long way from where we were with understanding the genome. So are you thinking that we will get to a stage where we will understand our connectome, and to the point that it can be then replicated in an artificial manner? So it's not actually so much so the original tissue coming back and being alive, but more maybe I feel like I want to make a reference to sci-fi here,
Yeah,
but a cyborg or something like that.
yeah, I would say it's taking the logical extension of current neural prostheses technology to its ultimate conclusion. So at the moment, people have probably heard about people who've had spinal cord injuries or lost limbs or lost the ability to speak after a stroke, for example, but they've had those functions partially restored through some sort of brain implant that has taken over the function of what was lost, where they're given a bionic limb or they're given some interface that, enables them to speak through a sort of artificial means again. The idea of what I see is, well, we get better and better at understanding how to make those things and how to make them for more and more brain functions. And we also get better and better at understanding how the brain works normally and naturally, to the point where we can essentially recreate a human brain. And we can also scan the information present in a human biological brain in a way where we can recreate it in a new sort of artificial format. And if we do that just right, in high enough fidelity, then hopefully we'd be able to restore a person to consciousness that way. I mean, there's a lot of philosophy, neuroscience, everything to really drill into whether that's possible and how one would do it. But that is the general argument that I'm making. Yes.
And what I thought was very interesting is that you also went into just how much it would cost. And I think you were touching on it briefly before, is about the fact that we have the technology available now, but we don't have the awareness, we don't have the funding and the resources allocated to it. So much so that you actually put a call out to different people working within different industries to say, if you want to see this happen, you need to be having conversations.
Yeah. No, exactly. I mean, so there's two things. Again, I would say the cost of doing preservation and storage is a lot cheaper probably than the cost of doing revival, which at the moment is roughly infinite because we can't do it at all. And also it's the case that even if we don't know which specific revival method we'll be able to use in the future, I think there's a strong case that preservation works well enough that it'll be compatible with at least one of the forms of revival that will become available, whether that's uploading or whether that's direct restoration of reversing the fixation, whatever it may be. So in the book, I really try and say, well, if you think these ideas are at all plausible, then how much is it worth to spend on this, on preserving people? Because on the one hand, if it costs $1 billion per procedure, then, it's of use to basically no one, even if you can guarantee it works. And if it's incredibly cheap, well, then even if you're not that confident that it will work, it might still be worth exploring, the same way as insurance or any other sort of speculative prospect. And so what I get into in the book is like, how do we actually decide how much to pay for medical treatments generally? So in a more concrete and more everyday sense, people have probably heard about the fact that there's constantly new cancer therapies that are being developed, but that often come with very expensive price tags. So $50,000, $60,000 for these new treatments. And when deciding whether that's worthwhile or whether it's not, what we have to look at is how much more time in what level of health do these treatments buy for someone versus how much does it cost? And in Australia, with our public health system, we use a threshold of something like $50,000 per year of healthy life, where to make that concrete, that's saying that, if your cancer drug costs $50,000, but it cures someone's cancer and gives them 10 years, then that's great. Yeah, we'll absolutely fund it. But if it costs $200,000 and it only statistically improves, survival rates by about a month or so, then we decline to fund that. We don't think that's a good use of resources in comparison to what else it could be. To bring that back to preservation, the conclusion I have is that if done at scale, preservation and storage should probably cost something like $10,000 to $20,000 per procedure, which means that, as long as you think it has some chance of giving people only a few more years of healthy life, then it's probably a worthwhile thing to be considering.
And tell me, we've discussed the possibility of this happening. We've done the mapping of the connectome. We've done the process of the preservation. But it's really that other side, isn't it? And I love how you speak about really the future and how we're dependent on the generations that come after us to actually like us enough to want to be able to revive us.
Yeah. I mean, this is a common question people ask. They say, like, even if you can guarantee me that the technology works, why would people in the future want to revive their ancestors? Like, why would they even care? For me, the reason why I think they might care is the same sort of reasons why I am grateful to my ancestors and the people who came before us. For example, I mentioned earlier that 1 in 2 children used to die before the age of 15. But because nowadays we have things like antibiotics and clean water and sewage systems, that doesn't happen anymore. And I get to live as a result of this. And I'm very grateful to everyone who worked in previous times to make the world a little bit easier for themselves and their children and their grandchildren. My hope is that should we meet the challenges of our time, things like solving climate change issues, things like preventing nuclear wars, things like ensuring that everyone has access to economic security, that we continue to build a better and better and better world to the point where hopefully people in the future will be living in such nice conditions that they're like, yeah, why not bring back our ancestors who helped give us this world? And on the other hand, if we fail, if the world is destroyed, or if it's merely just an impoverished sort of condition, then nobody's going to be bothering to bring back their preserved ancestors. So it's sort of both a hope and also an impetus to like really take seriously that there will be a 2100, there will be a 2200. Like the future is going to happen the same way that the past was really real. And we should want that to go well, both for our descendants and maybe a little bit also for ourselves.
And is that one of the biggest hurdles with this, is that we're trusting humanity to do the right thing?
Yeah, I mean, it's an uncertainty with all endeavors, and particularly this just makes it very concrete. If anyone wants to build anything, whether it's improving the governance of their country, whether it's building a business that lasts into the future, whether it's ensuring that their children and their grandchildren have good educations and good lives, there's always a degree of like uncertainty about how the world is going to go, how future humans are going to act, and how we're going to act today. And normally we just, think that that's a problem, but we don't dwell on it too much. But if you're really concretely thinking about, hey, is there a chance that I will exist in 2100 or that I need something from someone at that future time point, I guess it makes very explicit this uncertainty that is there. But I think uncertainty is not the same as, it will definitely fail, in the same way that I think people who lived in 1500, 1600 or so would be very pleasantly surprised by actually how well the future went compared to the living standards that they had.
And I think that you do a good job of also drawing on past quotations from people who were quite visionary in our past that have, thought about an idea or what our world could possibly be. And some of those things have come true. So, it does pose the question that people have asked these things in the past and they have become a reality for us today. And that's what I really like about the book all the way through, is that you're being challenged. Just when you think that, oh, maybe this isn't a possibility, then you challenge me or provide me with another reason about why someone in the past may have had the same concerns about, things that we've already been able to accomplish in medical, achievements. Something that I went to recently was an exhibition in an art gallery in Gippsland, and it was a beautiful collection of drawings based on centenarians. I'm always horrible at that word. I can never pronounce it properly. For those of you, people who have reached the ripe old age of 100. And a lot of them didn't know how they made it that age. And a lot of them had a sense of grief about them because they were the only ones left of their loved ones and their family. So, do you think the success for something like this is making sure that it's not just being offered to the few, but being offered to the many?
Yeah, absolutely. I think this is, in the same way as all medical technology, something where you want as many people as possible to have access to it, and something that should be used to empower people generally. Now, that's not to say that if for whatever reason only a few people take it up, that it's not worthwhile. In that it sort of reminds me of how my grandparents were Holocaust survivors, for example, and they told me stories of friends of theirs who had had their entire families die and who had come to Australia as refugees with no connections, nothing, essentially. Now, that was horrible for them, but at the same time, they still went on to have meaningful lives, to build new connections, to build essentially a new and satisfying life for themselves, despite having lost everything previously. And in the same way, I think that even if isolated individuals wanted to make use of something like preservation without their friends or families or others, then that might still be worthwhile for them. But it's obviously the case that the more people have access to this, the more people whose communities are kept intact, who get to live again with their friends and family and loved ones, the more this has succeeded. I definitely think it should be accessible to everyone.
And I suppose here's the big question, Ariel. Would you sign up for it?
I absolutely would. Were I, for example, given a terminal cancer diagnosis or something. I'm only 32 at the moment, so my hope is I won't have to make that choice explicitly anytime soon. But it is the case that when, for example, I've looked at surveys of the terminally ill and their will to live, where people have gone into hospices and they've asked people at death's door, do you still have a strong will to live? Most people in that circumstance, about 70% when asked, continue to say, I have a very strong will to live, even right up until the end. And I think I would likely be the same. And if someone could credibly offer me some way of being able to live longer at some point in the future, then that is something I would push very hard to take up. Because ultimately, I think it is the case that these things should be under individuals' controls. People should be able to, if they want to, I guess, end their lives at the point where they're suffering huge amounts of pain or where they no longer feel their life is at the quality that they want it to be. But on the other hand, if we have people who are terminally ill, but who think that this might give them some chance at more time, it's absolutely something they should have access to as well.
Wow, I think that's amazing. So, how do you think that the role of grief and mourning comes into this process? If someone does choose this as an option, how do you think that that might play out for those loved ones left behind?
Yeah, I have not thought a huge amount about this, to be fair. And I'm also not a sociologist or a psychologist in grief. So
Of course.
I put some, caveats on what I'm
Yeah, of
about to
course.
say. My guess, and this is just a guess, is that it seems somewhat similar to sort of what was actually historically more the norm, where most people used to believe in an afterlife, a religious sort of afterlife for people, where they would, their loved ones would die, but they might be reunited again with them at some point in the future in heaven or so. And obviously, this is a variant on that, insofar as there's no guarantee that this technology will work, either from a technical sense or that future generations will have the capacity to bring people back. So I think it's sort of two parts to it. There's the fear that their loved ones might be gone forever, but there's also just the loss that even if they are sure they'll get to see their loved ones again at some point in the future, they've still lost them for now. They're still grieving the loss of their friendship, the loss of their family member, all the time that they won't spend with them. And I imagine that's got to be pretty similar to the standard sort of grieving process. At least that's how I think about it. Even if someone could guarantee me that I'd see my friend again in 100 years, I'd be pretty devastated that I wasn't seeing them now.
It's interesting because then it comes back to that age old challenge between faith or religion and science, and that the possibility of an afterlife. So, this would be a scientific, version of really an afterlife, wouldn't it?
Well, I mean, I guess in a technical sense, I would argue that the person never really died, so it's not quite afterlife.
That's true.
But it
Yeah.
is, yeah. There is a strong analogy, I think. It's fair to make.
This has been absolutely fascinating. I've loved the book. I've loved reading it. It's taken me through so many different avenues and just really made me appreciate just how difficult it is and how complex we are as humans, and how far we've come in modern technology and science. For anyone fascinated about the next steps, how can they advocate? What do you suggest people do to support this kind of, future that you're suggesting?
They are interested in general. I have an ongoing newsletter where they can find out more about sort of developments that are happening. It's called Preserving Hope on Substack. It's also available through my website. If they want more specific information about organizations helping push for this sort of stuff, they can look up, for example, the Brain Preservation Foundation. And if they're interested in the providers that actually currently exist in this space, the two to check out would be Oregon Brain Preservation and Connectome, which are in the west coast of the US. And hopefully, we'll be able to expand and grow to the point where they can start to offer services in Australia at some point in the near future. People should also feel free to email me if they're interested. And those details are also on my website.
That's fantastic, Ariel. I can't thank you enough for being a guest on the show today. I really enjoyed our time here.
I'm glad you had me, and I'm glad you're having these conversations with people. It's great.
Don't be caught dead forgetting to subscribe. And here are some more videos we know you'll love.